Hello, my name is Jeff Marvin. I'm the Design Center Manager at Linear Technologies Burlington Design Center. Today we're headed into the lab where I'll demonstrate rugged USB isolation using the LTM2884 isolated USB transceiver with isolated power. USB, or Universal Serial Bus, is a 4-wire interface, 2 for differential signaling, D+ and D-, and 2 for power, V-bus, which is 5 volts, and ground. This figure illustrates the simplicity of isolating the USB port. Now, before we exercise this device, let's take a brief look at what's inside. The LTM2884 micromodule includes 2 USB transceivers, each facing the outside pins, D+ and D-, while internally communicating across a pair of galvanically isolated signal inductors. The top section of the diagram shows an integrated, regulated 2.5 watt flyback DC to DC converter, complete with an isolation transformer, output diodes and capacitors, plus 3.3 volt LDO regulators that power each USB transceiver. Notice that the V-bus pin only powers the LDO to the USB data interface. VCC powers the isolated flyback converter and generates isolated VCC2. Power configurations will be discussed later. Here's an internal CAD drawing of the micromodule construction. The coupled signal inductors are labeled and are copper tracks coupled across a 100-micron thick 2-ply internal isolation layer of BT laminate, similar to an FR4 PCB material. The 2 USB data isolators are on either side of the coils. The DC to DC converter uses an integrated flyback converter die plus a tiny wound toroid core power transformer. Now we'll head into the lab and I'll demonstrate the LTM2884's operation and robustness, and we'll observe the rest of its features along the way. Here I have the LTM2884 demo board, the DC1789A, which includes the micromodule plus connectors. I simply connect the demo board to my computer's USB port and then connect a USB mouse to the isolator board. You see the computer screen and pop-up message indicating that the mouse is detected as new hardware found, just as you would see if the mouse were plugged directly into the computer. And I'm now controlling the computer with the mouse. No drivers or software are required with LTM2884, just plug and play. The mouse is a low-speed device, which the LTM2884 has detected and auto-configured for 1.5 megabit per second operation. The data transfer is displayed on the connected oscilloscope. Automatic speed detection is a key feature of LTM2884, and this diagram illustrates how standard USB pull-up resistors define the speed. D- is pulled high to define low speed, or D+ is pulled high for full speed. LTM2884 detects the resistor during bus idle time communication and mirrors the connection to the host side with internal resistors and integrated switches. Before discussing more operational performance, I'd like to show you the robustness of this USB interface. After all, this product is for isolating USB in harsh industrial or sensitive medical environments. Here, I'll zap a data pin directly with 20,000 volts IEC air discharge ESD. You should be able to see and hear the physical spark as I bring the tip of this ESD gun toward the post connected to the D2+ pin. Wow, but it's only impressive if the device still works. All 4 data pins contain rugged ESD diodes, and we specify 15 kV ESD ratings on each data pin and across the isolation barrier. This protects the peripheral or host from the plug-in of a pre-charged cable. Okay, the next fundamental operation I want to show you is connecting a higher speed device. Now I plug a memory stick into the LTM2884 board I just zapped. The memory stick is a true USB 2.0 compliant device capable of communicating at 480 megabits per second. As you see on this computer screen, when the high-speed device is detected, the speed is reduced to the maximum rate supported by the LTM2884, which is 12 megabits per second, the USB full-speed data rate. Now the computer is copying files to the memory device. The oscilloscope captures the isolated D2+ and - signals at 12 megabits per second. A key function of the LTM2884 is the internal isolated power supply, capable of delivering up to 2.5 watts. The VCC pin supplies power to the isolated side VCC2 through the DC to DC converter with 2500 volt isolation. VCC voltages from 4.4 volts to 6.5 volts will support 200 milliamps on VCC2 at 5 volts, while VCC voltages from 8.65 to 16.5 will support the full 500 milliamp load on VCC2. The power converter utilizes a variable frequency boundary mode flyback with a range of 5 kHz to 1 MHz. Now let's look at practical uses of the available power by using the LTP-2884. The LTP-2884 is a complete 2500 volt inline USB isolator based on the LTM-2884, featuring a rugged enclosure with high retention USB connectors, hot plug protection, power path, surge protection, and LED status indicators. Of course, no drivers or software are required, just plug and play. Since we've already powered a memory stick, let's move to a more power-hungry peripheral, a portable hard drive. When I plug the hard drive into the LTP-2884 box, we see an overcurrent LED light up, and the VBus2 powered hard drive doesn't spin up. However, the LTP-2884 includes an input power path ideal diode. I can plug in a 12-volt wall adapter, which will feed the LTM-2884's VCC, increasing available isolated output power to the full USB spec of 500 milliamps and successfully powering up the hard drive. You can see the hard drive has connected and is displayed on the computer after enumeration, and I'm able to transfer files. Since we still have the hard drive connected, let's make things more interesting. The isolation offers protection of the computer or USB host equipment from damaging voltages, electrical disturbances, and noise. Here I have a powerful electric drill motor sharing the same ground as my hard drive. As I drive the motor, you can see on the oscilloscope high current spikes bouncing the local ground several volts, while data signals from another file transfer continue smoothly. In fact, the LTM-2884 works seamlessly through common mode disturbances as fast as 50,000 volts per microsecond, far worse conditions than this electric drill produces. Another primary use of isolation is to control or acquire data from electronics connected to a high voltage domain. Here we're floating a measurement system on a 100-volt supply. The system is a Linear Technology high-performance SAR ADC demo board, the DC1783A, which uses an LTC 2378 ADC, driven by a DC1858A sine wave generator. We're acquiring the data through the USB isolator, pulling the data from the ADC system with the DC718C P-scope interface board, and displaying the FFT results in P-scope. Whether or not you're an ADC expert, notice that the SNR results meet 97.5 dB as published in the demo manual for this system. This proves that the LTM-2884 blocks the high working voltage of this measurement application and does not introduce noise or jitter, which would degrade the SNR of this high-resolution data acquisition. One final topic is USB 2.0 compliance. An LTM-2884 designed into a peripheral device can be certified USB 2.0 compliant. However, some configurations of the VBus and VCC pins may affect compliance. Peripheral devices powered from VCC2 may increase inrush current from VCC that could exceed compliance limits. Designing the LTM-2884 into a hub or host may only be certified for USB 1.1, since USB 2.0 hubs and hosts are required to support high-speed communication. The LTM-2884 fully meets low and full speed USB command verification and data signal compliance. The eye diagram shown here was constructed under full speed 12 megabit per second operation, demonstrating the LTM-2884's compliance and high signal integrity, low distortion, low jitter, and high SNR. Another feature of the LTM-2884 is how it handles suspend. The suspend requirement in the USB spec is for a device to reduce power and go inactive when the data bus is idle for longer than 3 milliseconds. The LTM-2884 supports suspend mode by reducing VBus current to 1.5 milliamps, and in addition has a pin for selecting the operation of the DC-to-DC power converter during suspend. One choice is to not suspend power, which will keep the DC-to-DC powering VCC2. This allows the LTM-2884 to detect isolated site activity and respond properly, and meets the suspend requirement when VCC is powered separately from VBus. The other choice is to suspend power by tying the suspend power pin high so the DC to DC converter is disabled. This will allow LTM2884 to draw only 1.5 milliamps in suspend when VBus and VCC are tied together. With VCC2 unpowered, the isolated side cannot communicate new connection, disconnection, or remote wake-up functions. On a resume from the host, the isolated side will recover power, but will require re-enumeration by the host. In summary, I have shown you the functional features of the LTM2884, thoroughly discussed USB 2.0 compliance, and demonstrated straightforward, high performance, and very rugged operation. The LTM2884 simply works. It handles harsh conditions, provides plug-and-play operation without requiring any software drivers, and is available to evaluate on several Linear demo boards. Finally, I want to be sure to mention Linduino, which showcases LTM2884, providing isolated access to Linear's wide offering of quick eval boards. Please visit linear.com for more information. Thank you for watching.